Lesson 1-7, Functions. Essential question. How do you determine if a relation is a function? Now remember that a relation is a set of ordered pairs. And a relation can be displayed in many different ways, such as a graph, a mapping, a table, ordered pairs, as I just mentioned. But now we have to determine whether or not a relation is a function. Some relations are functions, some are not. So to determine if something is a function means that for every input, which is our x variable, there is only one output. So y. So for every x, there is only one y. Now one of the tests that we do in order to determine if a relation is a function is a vertical line test. Now a vertical line test is only done for graphs. So a vertical line test can help us figure out whether or not a graph is a function. So determines whether or not a graph displays a function. So anytime we see a graph in this lesson, we're going to do the vertical line test to figure out whether or not it's a function. Then when we encounter ordered pairs, tables, or mappings, we're going to look at the input and the output to determine whether or not a relation is a function. Okay, so let's start with a graph, meaning we're going to do the vertical line test. So the directions say, are these functions explained? So we're going to want to say yes or no and why. So here's how we do the vertical line test. The blue line right there, that graph is called a parabola. We're going to take the parabola and draw vertical lines through it. So if I just start from left to right, if I draw a vertical line through my parabola, I'm going to look at how many times does this vertical line touch my blue parabola. Now this red line touched the blue line just once, right here. If it only touches once, it is a function. But I've got to keep making more vertical lines to double check and make sure. So I'm going to move from left to right, make another vertical line. My red line touches the blue line only once. So yes, it's still a function. Let's do one more line. My red line intersects my blue line again only once. So it is a function. So this one is yes. And the reason why is because it passes the vertical line test, or VLT. So the reason why it's called the vertical line test is you're going to draw vertical lines on your graph. If your vertical line touches your graph only once, it's yes. If it touches it more than once, it is no. And you'll see what a no looks like in a moment here. So now this time, we've got a graph that looks like a V on its side. So if I start by drawing a vertical line, so notice my green line touches the pink graph only once. So far this one is a function. But if I make another vertical line, you'll notice that the graph is touching my vertical line twice now. As soon as your graph touches your vertical line twice, your answer is automatically no. Let me show you again in one more spot how it's going to touch twice. Once here and once here. Since it is touching twice, this one is not a function. and I'm going to say it fails the vertical line test, or VLT. So if I go back up to my other graph, this red line touched the blue line just once, just once, just once. So that's why that one could be yes. But this one, since it was twice, it is no, not a function, fails the vertical line test. All right, so now you're going to see a little bit of a different graph with just coordinate points graphed, but none of our coordinate points are connected. We don't want to connect them. We leave them separate, but we're going to draw a line, a vertical line, through every one of these coordinate points. Remember, anytime there's a graph, we do a vertical line test to see if it's a function. So start on the left. Red dot only touched my green line once. One red dot touching my green line. One red dot touching my green line. Once, once, once. So this one is yes, passes the VLT. Now this one is just one vertical line. So if I draw a vertical line on top of another vertical line, I've got to figure out, is this one yes or is it no? So let's look. Is my red line on my blue line right here? Yep. Is my red line not touching my blue line here? Yes. Here, yes, 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 yes. And that would keep going forever as those lines extend in both directions. So this one is no. These two lines, my vertical line on top of my graph, would touch an infinite number of times. So no, remember, 2 or more is no. So no fails the VLT, the vertical line test. All right, now we're going to move from graphs to tables to determine whether or not these tables display a function. So now we're no longer going to use the vertical line test. The vertical line test is only for a graph. Now for a table, we have to look at our x values, which is our domain, and our y values, which are our range. Remember, from the vocab, for every x value, there can only be one y value if it's a function. So what you're going to do is you're going to look at your x values. So my x values are -7, 4, 2, and 5. No numbers repeat, and that's what matters to me. So I'm going to write no repeats. If every one of my x values does not repeat, then for every x, there's just one y value. So I'm going to say yes, the x values do not repeat. So for every x, there's one y. So now let's look at this table. Same thing again, where I'm always going to look at my x values. You don't need to look at the y values. That's not what we need to focus on. We need to focus on the x values. Now notice there is a number that repeats in our x's. 3 and 3. This 3 goes to +2. This 3 goes to -1. Now remember, it's a function if for every x value, there's one y value. This time, we have our x value of 3 going to both the 2 and the -1. So this is no, because there is a repeat. So we're going to say no, the x value 3 repeats. The x value 3 repeats. if you make the connection with this back to a graph, let me show you how these work together. So if I make a coordinate grid, and I graph these 4 coordinate points, so 3, 2, 1, negative 2, 2, negative 4, and 3, negative 1, and I do the vertical line test, touches once, touches twice, here and here, so it is no, which is what we said. So if you were a visual person and you wanted to graph that to determine whether or not it's a function, you could. It is not a function because it would fail my VLT if I graphed it. All right, now we're going to look at mappings. So mapping is just like a table where the left hand side is my x values, the right hand side is my y values. So again, I want to ask myself, do any of my x values repeat? We only care about our x values. We've got a 1 and a negative 1, but those aren't the same, so there aren't any repeats. So this one is yes. None of the x values repeat. Now what can confuse some people on this one is that we've got 3 arrows going to this 3. But we don't care if the 3 repeats. Remember, if I wrote these out as ordered pairs, it'd be negative 1, 3, 0, 3, and 1, 3. We don't care that these 3's repeat. That doesn't matter to us. We only care if any of our x values repeat. All right, here's another mapping. So let's look at our x values. So the negative 10 goes to 0, the negative 8 goes to negative 2, and then you'll notice that there are 2 lines leaving the negative 3. This means that negative 3, 1 is one ordered pair, and negative 3, 4 is another ordered pair. So if I wanted to write this as a table, my coordinates would be negative 10, 0, negative 8, negative 2, negative 3, 1, and negative 3, 4. So if I looked at my left-hand side, my x values, negative 3 repeats, so that is not a function. So no, the x value 3 repeats. So if you ever see a mapping with an x value that has 2 arrows leaving it, it's not a function. Here's another mapping. So if I look at my x values, now look at this one. This one only has 1 arrow leaving each number. So that means none of them repeat. So I can say yes, no x values repeat. All right, so now we have a click and drag for function or not a function. So we've got to look at each one of these and determine whether or not they're a function. So let's start with the tables. So I'm going to take this table and I'm going to look at my x values, which is my domain column. I have 2 negative 5s in my x column, so that makes it not a function. On this one, none of my x values repeat. Negative 4, 3, 4, 9, and negative 3, so that one is a function, no repeats. This one, if I look at my x values, 2, negative 2, 5, negative 1, none of those repeat, so it is a function. This one I've got 2 6s in my domain, so that one is not a function. Now if I go to mappings, what I really want to look for is, are there any numbers that have 2 arrows leaving the domain? That one doesn't, so that one's a function. This one, the 4, has 2 arrows leaving it, so that one means an x value repeat, so it's not a function. This one, same thing. I've got 2 arrows leaving the number 2, so therefore it is not a function. This one, just 1 arrow leaving all of my x values, so it is a function. If I take this one and do the vertical line test, touches twice, touches twice, touches twice, not a function. If I take this one, touches once, 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 it is a function. Twice, 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 not a function. Touches once, but then touches twice, not a function. Running out of space here, but once, 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 function. Now, ordered pairs, we've got to look at our x values to determine whether or not it is a function. I've got 5, and I've got 5, so I have an x value that repeats, so that means that one is not a function, because that 5 repeated. A relation is a function if